Alright, let's go. Number 10. The edge wasn't where anyone thought for decades. Scientists were confident they understood where the solar system ended. Models had been built, boundaries had been estimated, and the numbers had been agreed upon. There was a clear picture of where our sun's influence fades and interstellar space begins. Then Voyager actually got there. Voyager 1 crossed into interstellar space at around 120 astronomical units from the sun, far beyond where many earlier estimates had placed the boundary. The edge wasn't just distant, it wasn't fixed, and, in a very real sense, it wasn't where the textbook said it would be. Now imagine traveling billions of kilometers through space, guided by theories built over generations, only to realize the boundary of your entire solar system had been misread. The universe didn't move. Our understanding had simply been wrong. Number 9. The solar system has no clean edge. We tend to picture boundaries as sharp lines, a wall, a clear division. But what Voyager found as it approached the edge was something far stranger. There's a turbulent region called the heliosheath, a vast chaotic zone where the solar wind slows down and begins to mix with interstellar particles. It doesn't behave like a wall. It behaves like a storm front that never fully resolves. The environment shifts constantly. Forces compete. Structures form and dissolve without warning. The solar system doesn't end with a line. It unravels into something else entirely. Now imagine leaving your home not through a doorway, but by walking into a fog that grows thicker with every step, where the ground beneath you slowly changes texture and the air becomes something new, and you're never quite sure when you've actually left. Number 8. Space got more chaotic, not less. Common sense suggested that as Voyager moved farther from the sun, things would get simpler. Less energy, less activity, less complexity. The deep outer solar system, scientists assumed, would be relatively calm. Voyager found the opposite. Instead of emptiness, it detected a region filled with tangled, churning magnetic structures. Fields that form, collapse, and reshape like bubbles in boiling liquid. The farther it traveled from the sun, the more unpredictable the environment became. What was expected to be quiet turned out to be a restless, invisible ocean of competing forces. Now imagine space not as dark and silent, but as something that never fully settles. Something that doesn't care about your models. Number 7. Plasma density spiked instantly and without warning. As Voyager crossed the heliopause, the true boundary between our solar system and interstellar space, one of its instruments registered something dramatic. The density of plasma, the ionized gas that fills the void, didn't gradually increase. It jumped. Sharply. Suddenly. Like stepping through an invisible wall into a denser world. The particle density outside the heliosphere was roughly 40 times greater than inside. There was no visual signal, no warning, no gradual fade. The universe had changed environments around the spacecraft without announcement. Now imagine drifting through near-perfect emptiness for years and suddenly finding yourself somewhere heavier, somewhere fundamentally different, with nothing to see and no moment where you could say, that was the crossing. Number 6. The magnetic field refused to behave before Voyager crossed into interstellar space. Scientists had one clear prediction they were confident about. Beyond the heliosphere, the sun's magnetic field gives way to the galaxy's own field, and that galactic field points in a measurably different direction. It would be one of the most reliable confirmations that the boundary had truly been crossed. It never happened. Both Voyager 1 and Voyager 2 crossed into interstellar space years apart in different hemispheres of the heliosphere during different phases of the solar cycle, and both found that the magnetic field direction barely changed, not slightly off. Genuinely, stubbornly aligned with the solar field in a way that had no clear explanation. Scientists described it plainly. Nature hadn't read the theorists' papers. To this day, the alignment isn't fully understood. The best current theory is that the interstellar magnetic field is stronger than predicted, strong enough to act like a straitjacket around the heliosphere, compressing it and aligning the fields in ways the models never anticipated. Now imagine crossing a line that was supposed to change everything and finding that one of the most fundamental properties of space simply didn't get the memo. Number 5. The boundary held its position when it shouldn't have. Here's something that quietly unsettled the entire scientific community. The heliosphere, the bubble of solar wind surrounding our solar system, is supposed to expand and contract as the sun's activity rises and falls over its roughly 11-year cycle. That means the boundary should move. It should have been in a meaningfully different location when Voyager 2 crossed it in 2018, compared to when Voyager 1 crossed it in 2018, compared to when Voyager 1 crossed it in 2012, because those crossings happened at different points in the solar cycle, with different solar wind pressures. Both spacecraft crossed at almost exactly 119 astronomical units. The numbers were too close. The models had predicted movement that didn't happen. Scientists now believe the interstellar magnetic field is far stronger than expected, roughly twice the predicted value, and that pressure from outside is compressing the heliosphere into something more rigid and stable than anyone had imagined. The solar system's boundary appears to be held in place by the galaxy itself, and we had no idea. Number 4. Cosmic radiation flooded in the moment. Protection ended inside the heliosphere. We live inside a shield. The sun's magnetic field deflects a significant portion of the high-energy radiation streaming in from deep space. Particles accelerated by exploding stars, traveling at nearly the speed of light. We don't see it, we don't feel it, but it's there, and it's being stopped on our behalf. The moment Voyager crossed the heliopause, that protection vanished. Cosmic ray levels surged immediately. Voyager 1 found that the heliosphere had been blocking more than 70% of galactic cosmic radiation. Beyond the boundary, those particles streamed in from all directions, unfiltered, unimpeded, relentless. The solar system isn't just our home, it's our armor. And Voyager was the first thing we ever sent to the other side of it. Number 31 Crisis. Voyager 2 goes deaf and mute. In July 2023, a routine set of commands was sent to Voyager 2. One of them was wrong, or rather, the wrong version of the command was transmitted. The result was that the spacecraft's high-gain antenna drifted just 2 degrees away from the direction of Earth. 2 degrees. At 3 billion miles away, that was enough to sever everything. Voyager 2 couldn't receive commands. It couldn't send data. For nearly 2 weeks, it was effectively lost in interstellar space. Engineers could detect a faint carrier signal, a heartbeat, but nothing more. The spacecraft was alive. They just couldn't talk to it. In desperation, NASA's Deep Space Network station in Canberra, Australia fired a 100-kilowatt signal directly at Voyager 2, the highest power transmission the network could produce. The team had low confidence it would even be received. The antenna wasn't pointed at Earth. They were essentially shouting into the dark and hoping the spacecraft heard a whisper. It took 37 hours to find out if it worked. At 12:29 in the morning on August 4th, Voyager 2 responded. It had heard the shout, reoriented its antenna, and came back to life. Now imagine waiting 37 hours to know if the most distant spacecraft ever built still exists. That's what this mission has become. Number 2. Another crisis. Voyager 1 loses its mind. 5 months later, the other spacecraft began falling apart in a different way. On November 14th, 2023, Voyager 1 stopped sending readable data. The signal was strong. The spacecraft was clearly still operating, but instead of science and engineering data, it was transmitting a repeating pattern of ones and zeros, pure, meaningless gibberish. Engineers at JPL spent months diagnosing the problem from 15 billion miles away. In early 2024, they sent a command called a poke, a prompt for the spacecraft's flight data computer to return a full readout of its own memory. When that readout arrived, 22 hours later, they found it. A single memory chip had failed. Just 3% of the computer's total memory, a machine with less processing power than the device you're watching this on, had been corrupted. The chip likely failed due to a strike from a high-energy cosmic ray, or simply from 46 years of continuous operation. There was no replacement. No repair mission was coming. So the team did something extraordinary. They split the corrupted code into sections, rewrote it to function as separate pieces, and stored those pieces in spare corners of the flight computer's memory, all while communicating at the speed of light across interstellar space, waiting 45 hours round trip for each command to be sent and confirmed. It worked. In April 2024, Voyager 1 began sending readable data again for the first time in 5 months. Now imagine performing surgery on a 46-year-old computer the size of a small refrigerator located in interstellar space, using only radio waves. That's what it took to save it. Number 1. It's still out there. And it's still talking. After more than 47 years, Voyager 1 remains the most distant human-made object in existence. It has traveled beyond the planets, beyond the edge of our solar system's protective bubble, and into the space between stars, and it is still transmitting. This was never the plan. The original mission was designed to last a few years, a grand tour of the outer planets. Everything since then has been borrowed time. But borrowed time runs out. Both Voyager spacecraft are powered by nuclear generators that have been slowly losing output since the day they launched. Instruments are being switched off one by one to conserve what remains. The team makes careful, painful decisions about what to keep running and what to sacrifice. Eventually, the last instrument will go dark. The transmitter will go silent, and Voyager will continue traveling through interstellar space, out into the galaxy, alone and unreachable. It won't stop because it reached its destination. It will stop because it no longer has the power to speak. The edge of the solar system was supposed to be simple. A line, a boundary, a clear transition between here and everything else. What Voyager found was something far harder to accept. A chaotic, shifting region where the models broke down, where the physics behaved differently than predicted, and where the deeper you look, the less certain everything becomes. 2 spacecraft went out there. Both nearly went silent forever. Both sent back data that changed what we thought we knew. And somewhere out in interstellar space, one of them is still moving, still transmitting. Still, after nearly 5 decades, telling us things we didn't expect to hear. The universe doesn't give up its answers easily. Voyager just happened to be stubborn enough to keep asking.